right. Good morning, everybody. While I get the PowerPoint queued up here, if you guys could please get out your periodic tables. I'm just going to give you a quick intro for what our day together is going to look like. So occasionally I have decided that I'd like to try flipping our classroom, which means that on Tuesdays and Thursdays when I'm not there, I'm going to pre-record a lesson for Mr. Bailey to show you guys and go over with you and just give this a try. So I'm looking forward to getting your feedback on how you like it. But today we're going to be going over the first lesson of Chapter 10, which is all about moles. Okay. No, not these guys, although he is very cute. A mole in chemistry is simply an SI unit for the amount of a substance. Okay, what does that mean? So just like 1 dozen of something, like 1 dozen eggs means you have 12 of them, or 1 pair of socks means you have 2 socks. Those are both counting units. Okay, so a dozen doesn't necessarily mean it's a dozen eggs all the time, right? You could have a dozen eggs, you could have a dozen desks, or a dozen watermelons, okay? No matter what you have a dozen of, it means you have 12 of that particular thing. Same thing with a pair. You can have a pair of socks, or a pair of shoes, or a pair of chairs, okay? Everybody knows that if you have a pair of it, you have 2 of whatever it is, okay? The mole is very similar to a dozen or to a pair, okay? It's a counting unit. 1 mole of something is Avogadro's number of that particular thing, okay? So it's a counting unit just like a dozen or just like a pair. Now, what is Avogadro's number? Avogadro's number is the number of particles in a mole, and it's a very large number. Okay, so in 1 mole of a substance, there are 6.022 times 10 to the 23rd particles in that mole. Okay, so just like there are 12 particles in 1 dozen, there are 6.022 times 10 to the 23rd particles in 1 mole, okay? If you look at the 2 examples on the slide, if I were to tell you I had 1 mole of pennies, okay, that would be 6.022 times 10 to the 23rd pennies, okay? 1 mole of carbon contains 6.022 times 10 to the 23rd atoms of carbon, okay? And just to make sure I clarify, Avogadro is not the same thing as avocado. We all love us some guac, but not the same thing, unfortunately. You'll have to go to Qdoba later to get that. All right, so let's try and understand how big Avogadro's number actually is, okay? Because Avogadro's number is a rather large number. I'm going to write it out for you here just so you can kind of see how large 6.022 times 10 to the 23rd is. Okay? So 1 mole, we'll talk about the chicken in a second, but we're just going to write it out first. 1 mole is 6.022 times 10 to the 23rd particles. And that equals 1 mole, okay? Well, how large of a number is 6.022 times 10 to the 23rd? If we expand that scientific notation, you're going to add 20 zeros after these 3 numbers here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. All right, if I put my commas in every 3 zeros, this is how many particles are in 1 mole of a substance. Okay? That is a massive number, and it's difficult to understand. So over the next couple slides, the examples that I'm going to show you are simply examples of everyday objects and what they would look like if you had 1 mole of that everyday object. Okay, so in this particular example with this cute little chicken here, if you wanted 1 mole of chicken eggs, it would take 10 billion chickens laying 10 eggs a day for 10 billion years to get 1 mole of chicken eggs. Okay, it's going to take quite a long time to actually get that many chicken eggs, right? To get 1 mole of chicken eggs. Now, a couple other examples. If you look at these 3 examples, they all have to do with grains of rice. I like the middle example the best because it gives you another really great picture of how large 1 mole of something is. Okay. If you wanted to get 1 mole of rice grains, you would need to have every single grain of rice that has been grown since the beginning of time. And even then, you still wouldn't have 1 mole of rice grains. Okay. A couple other mole facts. I like the one all the way on the bottom of this slide, the green one, a hockey puck. Okay, at this point in your lives, you've all seen a hockey puck, played hockey. You know that a hockey puck is roughly that big, right? If you had 1 mole of hockey pucks, so 6.022 times 10 to the 23rd hockey pucks, your 1 mole of hockey pucks would be equal to the mass of the moon. Okay, huge numbers here. Oops, went a little too fast. From this slide, an example that I really like is the top one, talking about human cells. Okay, so each adult human being has roughly 60 trillion cells. Okay, in order to get 1 mole of human cells, the human population of the Earth would have to double. Okay, that's every single human being on Earth right now. If you counted all of their cells, there's only half of a mole of human cells on planet Earth right now. Okay, so moles are a huge number. Now, why is a mole such a huge number? The reason why a mole is such a huge number is because in chemistry we deal with things that are so small. Okay? Atoms, molecules, compounds are super, super, super tiny, tiny, tiny things. Okay, and if you're going to start to talk about chemical reactions or want to take and do chemical reactions or experiments, it would be very difficult to show an individual carbon atom reacting with an individual hydrogen atom because they're so, so, so tiny. However, if you deal with 1 mole of carbon atoms reacting with 1 mole of hydrogen atoms, it gets to be a little bit easier to see those experiments or see those reactions happen because now you have a large enough amount of those atoms to actually observe the reaction happening. Okay, so that's why the mole came about. Okay. Here's another good example of mole facts. We're going to keep going though. If you'd like to see this one or read it through, it's on the PowerPoint or the video. They're both posted to our website. Okay. So 1 mole of something, okay, is that Avogadro's number. It's 6.022 times 10 to the 23rd of that particular thing. Okay. However, because a mole is a counting unit, 1 mole of carbon does not necessarily have the same mass as 1 mole of hydrogen. Okay. So let's take a break from using the word mole for a second and help you understand that with a more familiar unit. If I were to give you 1 mole or 1 dozen limes and 1 dozen watermelons, those 2 groups of fruit have different masses, right? 12 limes is going to have a different mass than 12 watermelons. You should all be nodding your heads. Yes, Mrs. Casey, they're going to have different masses. Okay. If you don't know that, you need to go to the grocery store. Okay. But that's a good example to show you that using the same counting unit, 1 dozen, the two groups can have very different masses because you have 1 dozen of a different type of fruit. Okay. Well, a mole is just like a dozen. It's a counting unit. So a mole is going to have a different mass depending upon what you have a mole of. So if I have 1 mole of hydrogen atoms, it's going to have a different mass than 1 mole of carbon atoms, just like 12 limes or a dozen limes has a different mass than a dozen watermelons. So that brings us to our next topic, which is molar mass. Okay, molar mass is the mass of 1 mole of a pure substance. Okay, and as it turns out, when Avogadro was going through all of his experiments determining exactly how many particles are in 1 mole of a substance, he discovered that 1 mole of a substance has the same mass as 1 atom of that substance, with the difference being the unit. Okay, so let me explain. If you guys all look at your periodic tables and find helium, okay, should be over by the noble gases, okay. Helium has the atomic mass of 4.00 AMUs. Okay, that means that 1 atom of helium has the mass of 4.00 atomic mass units. When Avogadro calculated out the mass of 1 mole of helium atoms, so 6.022 times 10 to the 23rd helium atoms, 1 mole of helium atoms had the mass of 4 grams per mole. Okay? And as he began to look into other elements, a trend began to appear where the atomic mass and the molar mass had the same number. You have to use a different unit because the atomic mass is the mass of 1 atom, whereas the molar mass is the mass of 1 mole of a substance. Okay? Rocky. That's my dog. Sorry. So even though the atomic mass and the molar mass use different units because it's a different number of atoms, it's the same number. Okay. The reason why it worked out like that has to do with the element that Avogadro was using to determine all these numbers. All I want you guys to know is that you can get your molar mass of any element by using the atomic mass from the periodic table. Okay, so we're going to practice that. I want you guys to all look at your periodic tables, find cobalt, okay, and tell somebody sitting next to you or sitting around you what the molar mass of cobalt is. Okay. I'll let you guys pause here. You can just hit the pause button, and once everybody has found the molar mass of cobalt, then you guys can continue. All right, so what have we talked about so far? We now know that a mole is a counting unit, and in 1 mole of a substance, we have 6.022 times 10 to the 23rd atoms or compounds or molecules of that particular substance. Okay. We also know that molar mass is the mass of 1 mole of those atoms. Okay. Now, mass has a unit of grams. Moles is the number of atoms in a particular sample of an element or a compound. Okay. Or moles gives you the number of atoms in that particular sample. What we're going to do next is we're going to go through conversions, okay? Because if I were to give you a certain problem on a quiz or a test, and I gave you how many atoms of calcium were reacting with however many atoms of oxygen, you will likely need to convert that number of atoms into how many moles of calcium and oxygen, or how many grams of calcium and oxygen. Okay, because a mole is just another unit. So you guys need to be comfortable converting from moles to grams to atoms and backward and forward. Okay, just like first semester you did metric conversions where you converted kilometers to meters to centimeters. Moles are just another unit, so you need to know how to convert from moles to grams to atoms and vice versa. Okay? All right, so conversions. When we do conversions, a quick little review here. When you do conversions, you use something called a conversion factor. Okay? Conversion factors are fractions set up like this. Okay? Where you put your desired unit in your numerator and your given unit in the denominator. Okay, now the reason why you put your given unit in the denominator is because when you do the math and you multiply across the top and you multiply across the bottom, if you have the same unit in the numerator as you do in the denominator, they cancel out. So those given units end up canceling, leaving you at the end of your calculation with your desired unit. Okay, so that's one reason why we set up conversion units with our desired unit in the top and our given unit in the bottom. Okay, another thing about conversion units is that they are always equal to 1. Okay, let me show you what I mean by doing an example. All right, so let's use an example you're all familiar with. If I told you I have 15 pairs of shoes in my closet, but I want to know how many total shoes I have, you could calculate that using a conversion factor. I realize that you all could probably calculate that in your head, but I'm going to show you how you would do that using a conversion factor. Okay? All right. So here's where my conversion factor is going to go. My given unit was shoes. Okay? Or pairs of shoes, rather. So 1 pair is what I'm going to put in my denominator. 1 pair of shoes. Okay. In 1 pair of shoes, I have 2 total shoes, right? That shouldn't be news to any of you, hopefully. Okay. Now, the next step in converting pairs to shoes is going to be to multiply across the numerators, multiply across the denominators, divide if we need to, and then we should figure out how many total shoes I have if I have 15 pairs. Okay? Now, the reason why I can multiply by this conversion factor is because this conversion factor is equal to 1. Because 2 shoes is the same thing as 1 pair of shoes. Okay, it's the same quantity of shoes, just different units. Okay, because that's what a conversion factor does. It converts from one unit to another. You're not adding things, you're not subtracting things, you're just converting a number that's given to you in a given unit, and you're converting it into a different unit. All right, so let's do our math here. My pairs of shoes unit cancels out because I've got that unit in my numerator and I have the same unit in my denominator, so they cancel. Okay, I'm going to multiply across the top, so 15 times 2 gives me 30. Multiply across the bottom, 1. Anything divided by 1 is that number. So if I have 15 pairs of shoes, that means I have 30 total shoes. Okay? That should be no problem for most of you. Okay, you did conversions first semester. This is a simple example problem of what you guys are going to do now as you convert from moles to mass to atoms, or from atoms to mass to moles. Okay, so now we're going to go over specific conversion factors related to the mole. Okay, so you're going to have to write these down. There's little spaces in your notes for you to write them down, but as we practice converting from unit to unit, these three conversion factors are going to become your most often used. They're not the only ones you'll use, but you'll use these fairly often. Okay? So if and when you have to convert the number of particles into moles. So if I were to ask you something like, how many moles of sodium do I have if I have this many particles? You would use this conversion factor. Okay. The next conversion factor that you guys are going to use often is if you're converting from grams to moles. Okay, so your given unit is moles, your given unit is grams, and your desired unit is moles. So if I said, like, I've got 30 grams of silver, how many moles of silver do I have? You would use this conversion factor. Okay. The last conversion factor we'll talk about is if I wanted to know how many particles of a substance I had, and I gave it to you in grams. So if I said, using the same example from earlier, I have 30 grams of silver, how many atoms of silver do I have? You would use this particular conversion factor. Okay. Now, like I said before, these three conversion factors or ratios are not the only ones you will use. Okay. Occasionally, you will have to come up with your own conversion factor, but these ones are simply commonly used. Okay. Moral of the story with conversion factors is that you need to remember, no matter what, that when you are using or developing a conversion factor, your conversion factor should always be your desired unit over your given unit. Okay, every single time. These three are common conversion factors that you will use, but they're not the only ones that you will use. So when you have to come up with your own conversion factor, come back to this. Okay, conversion factors are always the desired unit over the given unit. Okay? All right, so now let's go over some practice problems. Okay. If I wanted to convert 3.5 moles of copper into grams, okay? Here's my my given is in moles, and I am looking for grams. Okay, so let's write out what we've got here. I have 3.50 moles of copper. Here's my conversion factor. Okay, my desired unit is grams of copper. Okay. The conversion factor that I am going to use is going to be how many grams are in 1 mole of copper, or the molar mass of copper. Okay, you can find that by looking at your periodic table. Okay, so look at your periodic tables. On the periodic table, find copper. The mass that you see on your periodic table, not only is it the mass of 1 atom of copper, it's also the mass of 1 mole of copper if you change the unit. Okay, so 1 mole of copper has the mass of 63.54 grams. Okay, Now I'm going to do the math. My units cancel. So for mole of copper, now I'm going to multiply across the top or across my numerator, multiply across my denominator. Okay, when I do that, calculator, sorry guys, 1 second. 63.54 times 3.50 gives me my molar mass, or my total mass in grams, of 222. Okay, now when you calculated that, you probably got a decimal, but remember to use sig figs. Okay, in all of our calculations here, our initial number has 3 significant figures, so our answer is also going to have 3 significant figures. So 3.5 moles of copper has a mass of 222 grams. Let's see if we're right. Ding, ding, ding. All right, a couple things to note here. This setup, the T-chart setup when you do conversions, if you like that, you can set your conversions up this way. That's no problem. I always set mine up using parentheses just because I like putting my conversion factors in parentheses like that. But you can set it up however you like. You're not going to get points off if you set it up like this because I do it differently. You're going to get the same answer either way. Okay. The other thing to pay attention to is that every single number in our conversion calculation here has a unit. That is important, and I will be picky about it. You need to be good about putting units on your numbers. And you need to be good now, because later, our next unit, in fact, is called stoichiometry. Okay? If you are not good at putting units on your numbers, when we get to stoichiometry, your papers are going to look like a sea of numbers, and you're going to get lost and frustrated, and it's going to save yourself a lot of heartache if you get into the habit now of putting units on your numbers. Okay? All right, so let's try another conversion. We just did a conversion from moles to grams. Now we're going to do one from grams to moles. Okay? So our starting unit, or our given information, is that we have 11.9 grams of aluminum. Okay? And we want to know how many moles of aluminum are in 11.9 grams. Okay? I know immediately I'm going to put grams of aluminum in my denominator and moles of aluminum in my numerator. I know that because grams is my given unit, moles is my desired unit. Okay? Now when I fill my conversion factor in, I have to use things that are given, or I have to use things that we know for sure. Okay? And we know for sure that the molar mass of aluminum is given to us in the periodic table. So if you find aluminum on the periodic table, you will find that 1 mole of aluminum has the mass of 26.98 grams. So 26.98 grams. All right. Now let's go through and do our multiplication, cross out our units. Okay. Come on, colors. There we go. Well, grams of aluminum and grams of aluminum will cancel. Okay, so now I'm going to multiply across the top. 11.9 times 1. Multiply across the bottom. 26.98. Okay. Then I'll divide. I'm going to divide 11.9 by 26.98. And that gives me 0.44 moles of aluminum. Okay, so let's process a little bit of what we just did there. This amount of aluminum right here, 0.44 moles, is the same amount as 11.9 grams. Okay, all we did here was we converted the units. 11.9 grams of aluminum is 0.44 moles of aluminum. All you're doing is changing the units. You're going from grams to moles. Okay. Now, today that's all the more converting we're going to do. All I want you guys to be able to do at the end of the day today is to convert from grams to moles or from moles to grams. Okay. Mr. Bailey is going to hand out some practice to you guys in a minute. That practice sheet, it's a pink sheet. It's got a whole bunch of conversion practices on there, a whole bunch of molar mass calculation practices on there. That sheet is due tomorrow. Okay. You guys can go through a couple examples with Mr. Bailey if you've got the time. And then with whatever time you have left after going through examples, you will have work time to complete that, and then we're going to check the answers to this worksheet tomorrow when you get to class. Okay? Best of luck. I'm excited to hear tomorrow what you guys think about the flipped classroom idea. Be good, and I will see you all tomorrow. Have a wonderful Tuesday, everybody. Bye-bye.